Hello students, today we are going to see the next code, 4-bit subtractor. In this we will be seeing the RTL code and the test bench. So before entering into the session, please subscribe my channel VLSA with Dr. Leena. Yeah, so what is 4-bit subtractor? A 4-bit subtractor is a digital combinational circuit used to subtract one 4-bit binary number from another 4-bit binary number, and it performs the operation A minus B. Here A is equal to 4-bit minimum number from which subtraction is done, and B is equal to 4-bit subtrahend where the number that is subtracted, and this produces difference 4-bit result, and borrow indicates if borrowing occurred during the subtraction. So let's see the subtraction operation, that is RTL code. Yeah, now we are going to write the 4-bit subtractor RTL code. That is, first we are starting with the module and we are giving the module name and opening the bracket. Here we have 2 inputs and 2 outputs. First we are going to assign the inputs and outputs. Look at here. First we are assigning the input A minimum, that is range from 0 to 3. And then we are assigning the subtrahend B, that is from 0 to 3. And next we are giving our output, that is the first output as difference and it is in reg. Yeah, now here the next output is borrow and we are storing it in the reg. And after completing the inputs and outputs, we are going to close the bracket. After closing the bracket, we are going to perform the operation. So we are giving always at open bracket, inside that we are giving star, closing the bracket and begin. This is nothing but the always block executes whenever input signals change, and this one in this, the star means all signals used inside the block, and this makes the block combination and logic. So whenever A and B changes, the subtraction is recalculated and begin starts the block of statement. Now let's go to the operation. Look at this. Here we have borrow and difference, that is equal to 1-bit binary 0 comma A minus 1-bit binary 0 comma B. Here the main subtraction operation is performed. In this, look at this. This borrow and difference are concatenation. This open bracket and close brackets are for combining signals together, and here it creates 5-bit results, that is difference 0, difference 1, difference 2, difference 3 and borrow if borrow occurs. And the next one is here this A, it extends to 5-bit, and this B also it extends to 5-bit. Why this extends means to capture the borrow bit. If borrow occurs, that has to be captured. So 5th bit ensures that it is capturing the borrow. And this equal to is called blocking assignment. It executes immediately in order inside the always block. After performing the subtraction operation, it ends, and then it ends the module, and this is the RTL code for the subtraction. Now let's see the test bench. Here to start the test bench, we are starting with the module and we are giving the module name. After giving the module name, we have to give the inputs and outputs using reg and wires. So first we are giving the input A, that is 4-bit, and input B 4-bit using reg, and then we are giving the output difference using wire, and then output borrow using wire. Now we have assigned the inputs and outputs, then we have to instantiate the RTL module inside this test bench. So we are going to instantiate the subtractor. Look at this. First we are giving the module name which we have given in the RTL code, and then unit under test, and we are opening the bracket and we are instantiating the test bench input with the module input and another input test bench input with the module input, and then we are connecting the test bench output difference with the module difference, and then test bench output borrow is connected with the module borrow. After instantiating every inputs and outputs, we are going to close the bracket. After closing the bracket, we need to do the test cases. For that, we are initially beginning. And after that, we are giving the test vectors. First, we are giving test cases without borrow, and then we are giving with borrow. We can combine and give, or we can give first with borrow and then give without borrow, whatever, however we want the test cases, we can give it. So the first thing is, first for A, that is 4-bit binary, I'm giving 0, 0, 0, 0, and B, 4-bit binary, 0, 0, 0, 0. I'm giving the first test case, that is A is 0 and B is 0, and I'm waiting 10 time units to complete the operation, and I'm giving the next test case, that is A is given as 1 and B I'm giving 1 and waiting for 10 time unit. I'm giving the next test case, and then after giving the test cases without borrow, I'm going for the test case with borrows. That is, look at this. Next input is A is equal to 4-bit binary 0001, B is equal to 4-bit binary 0010. That is, look at here, 1 minus 2. Here, when we are subtracting this, we'll get the borrow. So we are giving the both the cases to know that both the cases can be given in the test bench. And here we are waiting for 10 time unit, and then we are executing the next test case, and then we are giving other test case. After we are giving one more test case, and then we are finishing the simulation, and then we are ending the module. So this is the test bench of 4-bit subtractor. Here first we are giving the inputs and outputs using reg and wire, and then we are instantiating the test bench and the module, and after that we are giving the test cases and we are finishing the operation. So let us see the output table, how it is going to come. So students, now we are going to see the output table. In this output table, first thing I have given the test cases which we have used in the test bench. Here we have given the 4-bit binary input A and 4-bit binary input B, and operation carried out, and difference in decimal, difference in binary, and borrow. First you look at the first condition, that is 0000 binary input of A and 0000 binary input of B. The operation performs 0 minus 0 and the difference is 0, and the binary number of the difference is 0000 and the borrow is 0. Similarly, you look at here, the input A is 0101, that is 5, and the input B is 0011, that is 3. The operation 5 minus 3 is equal to 2, and the binary difference is 0010 and the borrow is 0. So we can see one with the borrow, that is the input of A is 0001 and B is 0010, that is 1 minus 2, difference is minus 1, and its binary is 1111 and borrow is 1. So this is the output table of subtraction for the test cases which we are given. In the waveform, if we are simulating, we will be seeing these values and these values and this difference in binary and difference in borrow. So students, today we have seen the 4-bit subtraction, and now I'm teaching the basic level coding. After completing few codings, we'll be moving to little bit advanced level, that is we'll be moving sequential coding, and then we will be moving to project level codings. So if you want to learn from scratch till advanced level, please follow us and subscribe my channel VLSI with Dr. Leena. Thank you.